This is nothing exciting really, nothing too crazy or complicated, how to graph complex numbers. Now remember, complex numbers, we covered those way back. That was in chapter 1, everybody's favorite. That real and imaginary, like 5 plus 3i, where we have that a plus bi. Well, we're going to show you how to graph those today. Not a big deal. You're not on an x and y axis. You will be on a real axis and an imaginary axis. So I just got to show you how to do all of this. So complex numbers, of course, we know have two components. We have the real part and we have the imaginary part. So, just like it says, you need the two axes to draw them. And this is a nitpicky detail. I mean, it's not a big deal. But it's important that you label your axes when I draw these. Now, am I going to write the full real axis? I mean, probably not. I'm probably just going to write the word real there, okay? And then same for this guy, your imaginary. So the real is always the horizontal, always, real horizontal. Imaginary is the vertical. And we do need them labeled. We should label x and y. We're in rectangular coordinates. We should be having these labels real and imaginary when we start graphing. Okay, so here we go. Graph those. We're going to graph them all. I'm going to draw out my little coordinate plane here, real, imaginary, and get into it. So, of course, I'm going to label real, imaginary. I'm going to abbreviate. Okay. Now, I'm looking at the numbers here. I'm not going to get too carried away. The numbers are generally pretty small. So let's just put a handful of tick marks on here. And I notice most of them look pretty positive. We'll see what we need here as we go. So I'm going to do point Z1 in green. We'll color code. I'll color code anyway. So the real's 2. So I'm going to go right 2. And I'm going to go up 3. I know, isn't this exciting stuff? Right 2, up 3. This is what we're doing today, everybody. Elliot.
May I ask why you made 4 points on each axis?
It's just random. I just threw a handful on there.
So it doesn't matter.
I was just looking at my numbers to see what would fit. All right, 3 minus 2y. So I'm going to go right 3, and then we have to go, I need to add a couple, don't I? Down 2. Right, 3 down 2. And I'm going to label that's my Z2 point. Okay, we got to get wild. We have to do Z1 plus Z2. Ooh. Okay, so I'm just going to add them up first. If I add the reals on Z1 and Z2, I need 5. What's your imaginary part when you add these together? And for dramatic emphasis, I'm going to put a 1i. So we're going to go right how many? 5. So I think I need one more. And up 1. So I'm just going to put that as Z1 plus Z2. There's my little labeling. That is pretty exciting stuff. Questions on that? Okay, and again, the tick marks is I just to fit whatever I need on the graph. Clearly, if I had bigger values, I would have a bigger graph grid going. Now, we're going to do some more here, but we're going to have some inequalities. So remember, inequalities has an infinite amount of answers, and we show that on our graph by shading. So let's first set up our axes. And as always, we're going to label. Real is always the horizontal. Horizontal, I can't talk today. Imaginary. Okay. So let's just talk about this goofy looking notation. This, of course, is what we remember is our set builder notation. It's what it's called. A plus bi, so your complex number, such that I'm really zeroed in on this piece of it. A is greater than or equal to 0. Well, A goes to the real part. So that's really telling you we want all the points where the real is greater than or equal to 0. So I'm thinking about my real, remember, horizontal, greater than or equal to 0. We're going to be on which side? Right. So greater than or equal to, I'm going to put a solid line, because that's at 0, everything on the right side. I know, I'm almost like, really, this is what we're doing with the chapter 7. I got a really humdinger on the back going, there's going to be a circle. It's going to get wild. Woo! Any questions on that guy? Okay, I better speed it up. I see you guys doing the next one. Get it together. Almost like this is, yeah, okay. Real, and I'm doing R and I. Okay, I'm gonna do this part, because you've got two inequalities, we have to do them both. So I'm gonna do, of course, that one in green, I'll probably do the other one in blue. So the real part is less than 1. So I'm gonna first mark 1 on the real axis. Now, less than is on which side of that? Everything to the left. Now, less than, you don't have the equal to on it, so the line itself is dashed. And I'm just gonna lightly shade as much as I can on the smartboard to the left. Now, b greater than or equal to 0. So the imaginary part, remember, is the b. Now, the imaginary is your vertical axis. If we're greater than or equal to 0, are you above or below the x-axis here, your real axis? Above or below? Greater than?
Up.
Up. Solid line because of the equal to. Okay, so this looks like child's painting here. Final answers are where, for mine, the green and the blue overlap. So for dramatic emphasis, I'm just going to try to bold this in. And it looks like a kindergartner threw paint on there. Okay, there we go. Any questions on that? It's a little easier to do in pencil because you can lightly shade them and then bold in the final answer. Got them? Good. Questions? I see people still shading, so I'm going to wait a second. And that's the front side. We're halfway done already, kids. Woo! Okay. Back side's, I think, even easier. I know. I was like, really? This is what we're doing here? Okay. Now, next exciting, fancy vocab word of the day, we're going to talk about the modulus of a complex number. That's the fancy name, really, for the absolute value of a complex number. So I'm going to show you how to calculate that. It involves, get ready, Pythagorean theorem. Okay, so recall absolute value can be thought of as the distance a number is from
0.
On the number line. Now, for our complex numbers, you got your real and your imaginary. Now remember, A, that was our real, B, that's our vertical imaginary. It makes a right triangle, so of course you can get the hypotenuse of the right triangle with Pythagorean theorem. That is also our absolute value of our complex number. So your absolute value of your complex number is really, you're just doing Pythagorean theorem. So if I were to flash it back to some of those first points, if I were to like to make a right triangle here and I want the absolute value, I would just do Pythagorean theorem and get the hypotenuse, which is what we're going to do here in a minute. All right, find the moduli. There's the, that's the plural if we're doing more than one, of 3 plus 4i and 8 plus 5i. So one, just to show you the relationship on the graph. I'm not going to graph them both. I'm just going to graph the first one. So 3 for the real, 4 for the imaginary. I'm going to label. I don't know. So if we plotted that point, right 3, up 4, it would make your right triangle. We went right 3, up 4. I hope on this one, because we've all passed Ender's geometry, we could get the hypotenuse. No work. 3, 4,
Oh, I can.
5. That is your absolute value, aka your modulus. So I'm going to say for this one, I did this guy in red, that my absolute value is 5. Now, I don't want to have to graph them all, because, I mean, if we don't have to graph them, that's just kind of obnoxious, right? So I'm going to do this one old school. I'm going to go Pythagorean theorem. So, of course, your real would be 8, but we have to square it in our Pythagorean theorem. 8, 5, something is not a triple. And then, of course, my negative 5, we're going to square that. So you've got 64 plus 25, which is okay. What is your final answer? Square root of 89. Because that equals our hypotenuse squared.
Like right on.
If you're more of a visual person, of course, you could graph it. You would go right 8 down 5 and make your triangle and do it, Pythagorean theorem style. It doesn't matter to me. Your homework's just going to say to find it. If you like the picture, draw the picture. If you can just mental math it in Pythagorean theorem, do it, okay? Get it done. All right, graph, more graphs. We're on the home. Oh my God, are we almost done already?
Yes.
Yeah, I feel like I should come up with a story or something.
No, it's
back
okay.
there. I feel like I'm disappointing with not enough stuff today. It's like, man. Okay. So get your little graph going there. Get going. Get going. Get going. Now, remember, when it has that absolute value, this is the connection, what we have to remember for me to draw this. Absolute value. Remember, the absolute value of your complex number, I'm clicking it back, is, of course, the hypotenuse on a right triangle. Now, for ours, it says that hypotenuse equals 1. That's kind of vague, but kind of not. So I'm like, well, I could draw a triangle here and have a hypotenuse of 1, right? I could draw one here, have a hypotenuse of 1, hypotenuse of 1, hypotenuse of 1. I could get crazy, right, all the way around, which ends up making you a
Circle.
with a radius of
1.
Okay, let's draw that. So circle, radius 1. So I'm just going to up 1, right 1, left 1, down 1, and let's pray. Could be better, could be worse. I feel like it's a little too much on the left, but I'm going to work with it. Elliot, question?
I was gonna ask if you should shade in the circle, but then I realized it's just the points.
You just wait for that. Keep that thought, Elliot, though. Keep that thought. Because look at the next one. It's super similar, but I swapped out the equal sign to a less than or equal. So we are going to have to shade here. Now, I'm really going to start with the same circle, because of course you've got the absolute value being 1. Now, less than, look at your symbol closely, less than or equal to, so easy question, dash or solid circle?
Solid.
Solid because of the equal to. Oh Lord, okay, that's that point on the left, we go with it. Now, inequality means there's an infinite amount of points, less than or equal to 1. Am I shading outside the circle or inside the circle? Inside, because remember that is like the radius, and we're less than 1, so you're shading in the circle. If it said greater than 1, you would have shaded where?
Around it.
Around it. Hey, we're done. Any questions on that? Too easy. Okay, so your homework, just FYI, not that, you'll probably get it done in class, but just for the record, remember 8.3 is not technically on your quiz tomorrow. It's not, it's just your quiz is 8.1, 8.2. Seems too easy. So your 8.3 assignment, if I don't feel like a Google Classroom at all, is technically due Friday. So I'm not going to collect it from you tomorrow. If you want to table it for right now, that's fine. It is not on the quiz. It is not due until